So what we are going to cover in this particular video. So this is the roadmap for today. We will first start off with understanding a very important terminology when it comes to structuring data in SQL. That terminology is known as data normalization. We will understand what's the meaning of this particular term and what are the main points when it comes to understanding or ensuring your data is normalized in a SQL database. After that, we will take a look at primary and foreign keys. I know in the past three lectures we have used these terms a lot, but still I haven't introduced these terms formally to you guys. So in today's video, we'll take a deep understanding of what is a primary key, what is a foreign key, and how to declare these constraints when it comes to designing your table schemas. Next, we'll take a look at joins and aliases. So joins and aliases are the will follow our primary and foreign key constraints. And finally, we'll understand how to perform filtering when we are performing the join operation. So this is basically the entire roadmap for today. So let's start off first with understanding what is data normalization. But before understanding data normalization, the key thing that we have to discuss first is understanding why we want to split data into tables. For understanding that, let's take a simple example. Consider that you are designing a database for a company. So obviously, when it comes to companies, there are multiple different entities in a company. You have employees, then you have projects, then you have essentially some utilities that you are or the infrastructure that you have developed, right? So each employee would be given his or her separate machine to work on, right? So there are different entities which are involved in proper functioning of any organization. Now imagine that I just create one single table, and in that single table I'm storing everything that I need to keep a track of all different entities in a company. Let's say I have employee related information, so I'll use the same table to store all the information about employees, right? So employee names, employee birth date, etc, 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 right? So all demographic information about employees is stored in that table. Then I'm also storing who is the manager of that employee, which projects that employee is working on. So I'm storing the project related information also in that table. So if that employee is working on 4 different projects, then entry of all the 4 projects should be available in the same table. After that, if that employee, let's say, goes out and tries to, get a couple of more machines for his team. Let's say he's finding that a single system is not complete or not fulfilling his, utilities. So therefore, he might raise a request for one more machine. So all the machines which are tagged to that employee, those are also attached in that same table. And you can imagine that the size of this table will keep on growing and growing and growing as you keep on adding entities or columns into a table. And beyond a certain point, it will become completely non-manageable. Right? So beyond a point, you would be essentially not be able to keep a track first of all of how many columns are there. Then if you want to even change a small thing, let's say for example, you want to tag that employee, or let's say that employee has left the company. So now you would want to delete all records of that employee from that table. So since now, what will happen, since a particular employee can be tagged to 4 tables or 4 projects or 5 projects or 10 projects. So for each employee, you would have those many number of rows being duplicated in the same table. And then you would have to search all the occurrences of that employee in that table and then delete them and make sure that no inconsistency is happening when you are performing that operation, which is a huge cumbersome task, to be honest, right? So you cannot keep a track of every all columns and be extreme, because just by mistake, accidentally, instead of mentioning the correct project employee name, let's say you also provided accidentally a project ID which was that employees for which that employee was not a part of. In that case, you would accidentally delete rows for other employees as well, right? So that's why it's completely illogical to keep everything into the same table, right? So from the perspective of both space management as well as convenience, you would want to split your entire data into individual tables, right? So the answer to this question of why we want to split data into separate tables in the first place is basically twofold. The first answer comes from the convenience perspective, that is from a programmer's perspective. It's much more convenient for you to keep a track of each individual table, that is an employee table, a projects table, a resources table, etc., right? So all these tables, if maintained separately, would even allow you to keep a track of each one of those tables individually without, or and if let's say if you wanted to delete an employee, simply you would go and delete that record from the employee table without even touching the records from the other tables, right? So all other tables would remain untouched. Only the table for which that employee is a part of, you would go ahead and remove those rows. So it becomes much more easy for you to operate and manage that table. Similarly, and the second advantage that you would get is you would not be duplicating records again and again and again. So the data redundancy portion also gets handled. For example, as I mentioned, for each employee, you would have a lot of demographic information like employee name, employee birth date, contact information, right? So joining date, salary, manager, all those are basically the demographic columns about an employee. And every time you want to tag that employee to a new project, you would have to copy the same rows again and again and again and again, given that you are storing all the columns in the same table, right? So every time that employee gets tagged to a new project, you would have to again copy paste the same demographic rows for every column. That's the only way you could ensure consistency of columns across each row, right? So that is introducing a huge data redundancy because same information is getting copy pasted again and again and again, which is not that efficient. So from the perspective of data redundancy as well, you would want to split your data into separate tables. So for that purpose itself, the concept of data normalization was introduced. And this topic of data normalization actually talks about how data is stored. Right? So whenever you create a database, the job of database creation is essentially not just limited to creating a database and putting a table in that database and populating the table. No, it's just one side of the equation. You also have to think about properly structuring those tables so that when you later on run queries on those tables, because storing the data is not just the only thing that you want to achieve. Right? So the real value of data comes out at the later point of time when you actually want to use that data to generate value from that data. And you do that by running queries, you run analysis, you train machine learning models, and you do whatnot. And everything requires an efficient underlying system which can run queries in an extremely fast way. And that is where the concept of data normalization comes into picture. Right? So whenever you talk about storing the data, you would also talk about properly structuring the data as well. Right? So how do you want to structure and store it? And that's where the data normalization comes into picture. So here are the essential 3 points that you need to understand when you are talking about data normalization. So these are the 3 questions that you need to ask yourself whenever you go about creating a database and you want to answer the question of is my data properly normalized or not. The first question is, are the tables storing logical groupings of data or not? For example, as I have mentioned, so whenever you want to create a database for a company, now obviously the logical grouping essentially means that, let's say if you are storing some information about employees, then all employee related information should be a part of that employee table. So you should not do things like, let's say in my employee table, I have kept columns like employee name, birth date, contact information, address and such. And then I am putting some other information related to manager or something else in a completely different table, right? So if you want a column to be tagged to an employee, then it should be a part of employee table. And secondly, if you want to know, okay, if this employee is later working in some other project, then there should be a separate table for projects, because projects is essentially an entity on its own. One employee will not work in one project, right? So it's not like one-to-one mapping between an employee and a project. There could be multiple people who are simultaneously working on one project. So keeping the project information in the employee table is completely illogical, because then what would happen is that again the concept of data redundancy would be introduced. So every time, let's say for a project you have 10 people working and you want to keep project information attached in the employee table only, then those rows for projects such as project number, project name, project start date, project end date, project budget, all those columns would be duplicated for all employees who are tagged to that project, which is again going back to the question of data redundancy, right? So first question that you have to answer is, are the tables storing logical groupings of data or not? So are all employee columns part of an employee table? Are all the projects column part of a projects table? Are all the infrastructure related columns part of that infra table or not, right? So everything should be a part of a logical grouping of data. That's the first question. Now comes the second question, which is, can I make changes in a single location rather than in many tables for the same information? For example, let's imagine that for some reason you have two entries of project information. One, you have a projects table in which you are storing all project related information. Plus, due to some reason, you have also stored the same columns in your employees table as well. Now, let's say in the future sometime, the project budgets gets changed, right? So let's say imagine that you are increasing the budget of your project. So now what will happen is that in order for you to reflect all the changes that has been made in that project, first of all, you would have to make changes in the main projects location, in the projects table for that particular project. And secondly, you would again have to make those changes for all the rows in the employee table for who are working in that project as well. If not, what will happen is that in the employees table, your information would be different, and in the projects table, the information would be different. Right? So there would be a conflict here, because information in the employees table is separate, whereas information in the projects table is different. So there's a big conflict which is happening here. So therefore, this is not the efficient way of doing things again. So here the question is, if you want to change anything, there should be a single location and at which you can make that change. And as soon as you make that change at that location, it should be properly reflected across all the tables who are making use of that information. So for example, if you have kept your projects table separate and if you have kept your employees table separate, in the projects table, you have stored information about who all employees are working on a project. So now, once you have changed any information about any project, then automatically you can pull the projects about an employee from the projects table, and the relevant change would automatically be reflected across the employee table as well. So therefore, the second question of what would happen if you make a change at a particular location. So if you want to update a particular row, do you have to go about performing the same operation multiple times, or can you perform that change in one single shot? That's what's the next question that you have to answer. And the third question is, can I access and manipulate data quickly and efficiently? Right. So that's the main use of any database, to access and manipulate data quickly and efficiently. So whatever you do, you should not be essentially running, you can say, unoptimized queries, because that's the only, you can say, bottleneck when it comes to using SQL. People learn SQL, but they don't learn how to write optimal queries using SQL. Right? So for that, you should need to access and manipulate data quickly and efficiently, and that will happen only if your data is properly normalized. Right? So for example, if you want to calculate total projects cost, right? So if you want to calculate for a particular employee, how much is the cost of that particular employee? So for calculating cost of any given employee, you would have to essentially go towards each and every project in that employee. For each project, you would have to pull out the budget for that project and how much milestones have been completed, and then based on that, you can essentially calculate how much what are the total costs that you have to pay. That, let's say, because some employees might be working on an hourly basis, right? So it might be a contractual employee. So based on number of hours that employee has worked on a project, you would want to calculate the total money that you are owed to that employee. So therefore, for that, you would again have to first fetch all the information about how many hours an employee has worked on a project, and then calculate what is the monthly, or you can say hourly rate for that employee for a project, multiply those two together, and then sum it up to calculate a total cost for that employee. Right? So it's a long process of calculation which you have to perform. And unless it's efficiently normalized, unless you have kept your employees table separate, in which you have information about the hourly cost for that employee, unless you have kept the projects table separate, in which you have the information about who all employees are working on a project, and finally, unless you have kept your cost in which you are mapping how many hours of employee has worked on a given project. Everything until and unless it has been properly normalized, pulling information relevant from the tables would be not be possible, right? So there would be it would be extremely difficult for you to write queries which need to pull such tables information separately. So therefore, you need to be having a properly normalized database with the help of which you can perform these tasks efficiently. Right? So that's all data normalization is all about. So it's a proper way in which you have to answer these questions and make sure that your data is correctly normalized. Now let's imagine that you have normalized your data, right? So your data is normalized, it's perfect. There are no redundancies in your table whatsoever or your database whatsoever. And you have structured each table such that it has a logical groupings of columns. Everything that we had discussed in data normalization has been tackled, and you have properly structured everything into a nice database. Now comes the question, what will I do if I want to use columns from multiple tables? Right? It can happen. Let's say you want to know all the projects that employee is working on, or you want to calculate what are the total number of resources that has been tagged to each employee. Right? There could be multiple questions that you want to answer. And that is where the concept of joins comes into picture. So joins allow you to pull data from one or more table at a given point of time. So let's say you have two tables, an employee table and a projects table, and you want to use columns from both employee and projects table in your single query. So if you want to perform such an operation in which some columns have to be pulled from table A and some columns have to be pulled from table B, in order to do that, you would have to use joins. We will discuss joins in more details. But before we do that, first we have to understand the concept of primary key and foreign key, because joins use primary keys and foreign keys in order to properly run queries. So first we will understand the concept of primary key. I know we have discussed this in a lot, like briefly we have discussed this in the previous workshops, but now in this lecture we'll go into much more detail about how to properly create and use primary keys. So to define a primary key first of all is a column in a table. Right? So it's not something special, it's a regular column in a table, but it's not like every other column in your table. So there are some constraints which are imposed on a column so that it can be called a primary key column. So what are the two main things that you have to keep in mind whenever you declare a column as primary key? The first thing is that all values in a primary key column have to be unique. So there can be no duplicates in a primary key column. For example, in an employee ID case, wherein it's a primary key for an employee table, right? So each employee has its own, his or her employee ID. And in an organization, no two employees will have the same employee ID. So if you refer to the employee table in any company, you will always find a primary key of employee ID, which allows that company to essentially have a unique identifier for each employee who is working for that company. So the first main constraint is that it's a unique column. That is, all values in that column are unique. And the second one is that it cannot contain any null values. So you cannot have null values in a primary key column, and you cannot have duplicates in a primary key column. Right? So these are the two main conditions for a column to be declared as a primary key column. And second of all, in one table, you can have only one primary key. Right? So please listen to the words carefully. So I'm saying in one table, you can only have one primary key. But it's not like you can only use one column to declare a primary key. So primary key can also be created by combining two columns together. A lot of the times what happens is that in a table, you cannot identify a column which has all unique values. So therefore, but you can have a combination of columns working together to create unique columns. So for example, consider again, go back to the employee table. Let's say in your employee table, instead of having employee ID, you have a column called department, and you have a column called employee count in that department, right? So here the problem is that in that organization, your employee IDs are unique to each department, right? So let's say you have HR department, sales department, marketing department, right? So and you have maintenance department, right? So in a company, you can have different departments, and an employee ID is unique to each department, right? So employee ID 1 could be present in department HR, it could be present in department sales, it could be present in department, let's say, marketing as well. And you know that each of these departments will be present across multiple employees as well. So there is no unique column right now. But if you join the department column with the employee column, that is, let's say you have a department column and you have a employee ID column. So if you combine department and employee ID together, that is, department is HR. So HR1 will be different from sales 1, and sales 1 will be different from marketing 1, right? So all these combinations that you are creating will now become unique. So that combination will now work as a primary key. And such a primary key in which you are combining more than one columns to create a primary key is called as composite primary key. Right? So primary key can be created by either using one single column in which it does not have any special name, it's called just a primary key. But if you are using multiple columns to create a primary key, then it's called composite primary key. Right? So I hope that distinction is clear between what's the difference between a regular primary key and a composite primary key. The only difference is that both of them are working the same, right? So both of them are used as a unique identifier for each row. The difference is that in a composite primary key, you have multiple columns combined together to create a unique identifier for each row. Whereas in case of a regular primary key, it's just one single column working to be used as an identifier for each row. Now, before moving forward, let me quickly share with you how would you create a primary key in your SQL table. So for doing that, I have shared my screen. This company DB file has been shared to you after the end of previous masterclass. Now, in the same company DB file, you will find that we are using this company DB to create our company DB database. Right? So I've already explained briefly about some of the DDL commands which were a part of this database. So we are basically creating a company DB database. And in that company DB database, you will find that we are creating later an employee table. So I've already explained in detail about these columns which we are creating in the employee table. So after these columns have been created, towards the end you will find that I have defined one primary key constraint. Now in order to define a primary key, there are different ways. This is not the only way to declare a primary key. I'll explain all the ways here. But one such way of defining a constraint, a primary key constraint, is to use a constraint keyword. After the constraint keyword, you assign the name for that constraint. You can write any name here. The nomenclature here rules will follow the same rules that you use for naming a column. So the nomenclature rules for column also apply for the constraint names that you are assigning. So here you can see I have assigned a name for pk underscore employee, indicating it's a primary key for employee table. You can write whatever name you want. And after that comes the constraint definition. So here you can see, since this is a primary key constraint, so therefore I'm writing the word primary key, and then in brackets I'm writing the column on which this constraint has to be applied. So I want to apply this primary key constraint on my SSN column. So this is the column here, which is called employee ID. Right? So in this employee ID here, I'll be using this employee ID as my primary key. This is one way of defining a primary key constraint, in which after the column definitions are done, you can use the constraint keyword, give the name for that constraint, and simply write the constraint definition that you have. So in our case, the constraint definition is on the primary key constraint. So therefore, you will see I have defined primary key and the column on which this constraint has to be applied. And this is basically how you define your primary key constraint. This is one way of doing it. The other way of doing it is basically this. Let me explain this again. So the other way of doing it is essentially, I'll copy here. I'll copy this constraint definition. And the other way of defining a primary key constraint is you can also define your constraint immediately after writing the column definition. So here, if you see, you don't have to write over here. So because you already defined the constraint here. So after writing the column definition, so here you can see I'm writing the column as SSN, which is of the character type, which has 9 characters. I simply put the primary key keyword following that particular column definition. So this will automatically declare this particular column as my primary key column. All right. So if you have just one single column working as a primary key, right? So if you don't have a composite primary key, so to say, if your table definition does not require you to create a composite primary key, then you can also create a primary key like this. That is, immediately following the column definition, just put the primary key constraint after the column definition, and it will use this column as your primary key column. But if you require a composite primary key, if you require it, right? So if your definition here requires you to have a composite primary key, then 1 second, let me just change it. If your constraint requires you to have a composite primary key, then in that case you have to define it like this only, wherein you have to use the primary key definition, and within the brackets you write all the columns that are a part of this composite primary key. For example, over here, if I want to create my primary key by using the two columns together, that is employee ID and birth date, then I will write the two column names inside these round brackets, and this will create a primary key by using these two columns together. And you can create as many number of columns in this list, right? So if you want your primary key to be created by using 3 columns, employee ID, birth date, and gender, then you can also write it like this, right? So just simply write the comma separated values inside these round brackets, and it will create your composite primary key as well. So I'm again repeating, in case of composite primary key, use this particular syntax wherein you define the primary key after defining the entire table schema. In case of normal primary key, in which it's using only one single column, then you can also define it like this, wherein after the column definition, simply put the word primary key, and it will use that column as your primary key column. Right? So that's all about primary keys. Similarly, the next important concept when it comes to relational databases, it's not just unique to MySQL. First of all, let me just clear that. The concept of primary keys and foreign keys is available across all relational databases that are out there. So be it MySQL, be it Postgres, be it MS MySQL Server, Microsoft Server, whatever, right? So all those relational databases out there, they use the concept of primary keys and foreign keys. Now let's understand what is a foreign key. Now, if you remember in the first discussion that we had, in which I had explained you the concept of a relational database, in that what I had mentioned was, in a relational database, the data is stored in the format of tables, and your goal is to relate two tables together. And how do you define this relation? You define these relations with the help of foreign keys. For example, as I've already mentioned, in your employee table, you have employee related information, which will have a column called employee ID, using which you can uniquely identify any given employee in that table. Now, imagine that you also have a projects table. In that projects table, you have all the project related information, that is project ID, project name, project manager, project start date, project end date, project budget. All these project relevant columns have been put in a projects table. And let's say you have a third table, which is storing information about which projects are currently live, so project IDs, and employees who are working on those projects, and how many hours each employee has dedicated to each project. So on project 1, you have employee 1 who has worked for 10 hours. For project 2, you have employee 1 who has again worked for 15 hours. So the same employee is working on 2 projects, project 1 and project 2. For project 1, he has worked for 10 hours. On project 2, he has worked for 20 hours. Same way, for each employee, you have a record of which project he or she is working on and for how many hours he or she has worked on. So now, let's say in future, you want to relate these tables together. So obviously, in your works table or your works on table. So let me just go back to MySQL, in which we actually have these tables created, which will give you a quick understanding of what I'm talking about. All right, so here you can see I have defined my table called works on. So in this works on table, you can see that I have a column called employee ID. This employee ID column is storing the employee ID who is working on that project. Then we have a project number, which is the project on which this employee is working on, and the number of hours that has this employee working on, right? So for how many hours this employee has been working on this project. And finally, you can see a composite primary key which is defined for this column, and this composite primary key is a combination of employee ID and the project number. Because you know that in this table you can have multiple employees working on different projects, and you can have entries for the same project multiple times for different employees. So therefore, there is no single unique column in this table. So in order to create a primary key column, we are combining the employee ID with the project number, and this composite primary key will be used to uniquely identify each row in this table. So this is our works on table. And now in this works on table, what we need to define, we will also need to define some foreign key constraints. And why do we need to define foreign key constraints is the next question. The reason being that now we somehow want to relate this employee ID to the employee ID in the employee table, because otherwise if you haven't done this, then you would not be able to pull information from the employee table correctly. So here, if you want to relate this employee table with the works on table, right? So because here you only have the employee ID, you don't have any other information about that employee, right? So if you go back to the employee table, here all the other columns about the employee are present in the employee table. So therefore, you need a mechanism by which you can let MySQL know that in my works on table, the column of employee ID is a foreign key, which is referring to the employee ID in my employee table. So until and unless you have done that, until you have basically, until you are able to do this, let me just, sorry, this is incorrect. Let me just go back to my initial configuration, and I'll essentially run the script once. Right, so here you can see on the left hand side of your screen, we have our works on table. In this works on table here, you can see these are the three columns in our works on table. So now you, as I mentioned previously, that you would require some way in which you can relate these two columns together. And for doing that exercise is basically where we require the concept of foreign keys. With the help of foreign keys, we will be able to mention, okay, a particular column in table 1 is linked to a particular column in other table. And if you scroll down towards the end of the file, towards the final extreme end of the file, here all the foreign key constraints have been defined. Now again, you can define these constraints in your table schemas as well. It's not mandatory that you have to define a constraint only after your entire definition of the table is done. But this is just done towards the end to keep everything properly structured, so that at the beginning you have the table schemas, then you have the code in which you are using to populate the tables, and finally you have this code which puts all the constraints between tables. So constraint which I am talking about are these two. So if you currently focus on these two constraints, you will see that the first constraint which we are defining, it's a foreign key constraint, right? So from here till here, this is main syntax that you have to focus on. So in order to define a foreign key constraint, again, you have to use the keyword of constraint. So this constraint keyword is main. After that, you write the name of the constraint. In our case, the name of the constraint is foreign key. So therefore, I am defining a foreign key constraint. Then comes the definition of the constraint. So just like primary key, the only difference is that this time it's a foreign key constraint. And in this foreign key constraint, the first bracket contains the name from the existing table. So this table here should contain a column called ESSN. So works on table has a column of ESSN. And this ESSN column is referencing the SSN column from my employee table. So this is the syntax with which you define a constraint, a foreign key constraint properly. So I'll again explain the logic. So firstly, the first column here is contained in the current table. So the table for which the constraint is getting defined on. So my existing table should have a ESSN column. Then comes the references keyword. And after the references keyword, you have to write the column which it is referencing. So this time it is referencing the SSN column from my employee table. Similarly, this works on table also has a column called project number, if you see on the left hand side of the screen. This project number is a primary key in the projects table. So again, you can use a foreign key constraints to link those two columns as well. So here you will see that I'm defining a foreign key constraint, which is using the project number column from my works on table, and it is referencing the P number column from my project table. So my project table also has a column here on the left hand side. You can see this column of P name is basically a primary key, which is used as a primary key for the project table. Sorry, project number, not project name, project number. So here you can see this project number table. This is a primary key column. So at the bottom, you will find the keyword PK written against this column definition. This PK is short form for primary key. So this is the primary key here in the project table, and I want to use this primary key and reference it against my P number column in the works on table. So hence this PNO will be working as a foreign key in my works on table, which will reference the P number from my project table. Also, you can read through other foreign key constraints which are a part of the same company DB file, and you will find that using this constraint, you are able to link multiple tables together. So here you can see I have added a constraint. I think on the at the beginning here you will find a couple of constraints on the employee side as well. So I know that employee has a column called department number. So in the employee table, you will also have information about which department that employee is working on. So this particular employee, whatever department that employee is working on, that department information will be a part of the department table. So here this foreign key constraint is defined on the department table as well. So here you can see the DNO column from the employee table is a foreign key, which is referencing the D number table from the department table. So here you can see this department table has a column called D number, which is a primary key in this table, and it is used as a foreign key in my employee table. All right. So this is a very quick introduction to how you define foreign key constraints. And as I mentioned, it's not mandatory that you define the foreign key constraint using the alter table command. Even if you wanted, you can also define these foreign key constraints after you have defined your entire table schema. So in this case, I'm defining a simple foreign key constraint. Let me delete this because we have already defined a primary key constraint above. So here in this foreign key constraint, I'm accessing this column called supervisor SSN ID. So this column is a part of my employee table. Right? So this supervisor SSN ID is basically replacing the employee ID column from the employee table only, because each manager is also an employee of the same company. So it's basically pointing to itself, right? So in this case, this supervisor ID is a foreign key which is pointing to the SSN ID from the same table, right? Because a supervisor also is an employee because he's also working in the same company. He or she is also working in the same company. So therefore, logically speaking, it should work as a foreign key, and you can draw manager information also from the employee table itself. So the manager also would have his or her dedicated row in the employee table, and that is the idea here. So in this foreign key constraint, you are using a supervisor ID column from the employee table and using it as a foreign key, which is pointing to the SSN ID or the employee ID from the same table. So there are multiple ways of defining this. I have shown you both the ways of defining it. So that's all about constraints, foreign key and primary key constraints as well. So next topic which we have to discuss is of aliases, and aliases are very important because a lot of times whenever you perform any operation, what happens is that the output which you get doesn't contain a logical name for that operation. So let's say for example, here you are selecting some columns from a table. So after selecting a column from a table, if you want, you can give that column your own unique name. So I'll demonstrate it with an example only because it will become much more easier if you understand this with an example. So let me go back to MySQL here. So in this example here, what am I doing is I'm going to run a simple query on this in this example, and here I'll write the use of alias. Let's do select. Let's run a simple operation here. 1 second. I use the employee table only, and in this case, let me do a simple operation in which I want to sum all the salaries that I'm paying to my employees in my company, right? So I want to sum up the salary from the employee table. So this is a very simple operation which I'm running. In this operation, I'm adding all the salaries that I'm paying to my employees in my company. Right? So here you can see I'm running a simple operation in which the select statement is adding all the salaries from my employee table. If I run this operation, in the output, what you will see, the column name right now contains this definition of how you are selecting this column. So here you can see in the column name, you are getting sum of salary, which is not that good to look at. Although the value is correct, but wouldn't it be better if you are able to declare some of your own unique name, like so, and you can do that with your alias function. So the way you define alias is by using the as keyword. So after making the selection for a particular column, after the as keyword, you write how do you want it to be displayed in the output. Okay? So let's say you want it to be written as total salary. Right now, I want my alias to look like total underscore salary. So if I now run this, what will happen is that the operation will now have total salary written as the column name and not sum of salary written as a column. So alias, as the operation suggests, is the way to assign an alias to an operation. And you can allocate aliases to column definitions as well as you can allocate aliases to tables that you are selecting. Right? So if you are writing nested queries, we haven't discussed nested queries yet, so I'm not going to discuss right now how to define aliases for nested queries. When we discuss nested queries, I'll again revisit this topic and I'll tell you about how you use aliases in cases wherein you are using nested queries, wherein you are having a query which is written inside, you have a query inside a query. It's a little bit technical topic, that's why we will address it later on in a future session. But for now, you can use alias as to give a nickname for a particular column. So you can think of it like a nickname, wherein you have a particular operation, you have performed that operation and selected a column. Now you want to give a new name to that column, and you can assign that name with the help of an alias. For example, let me write another query. Here I am going to select some. Here I'm going to select sum of salary, and let's say department number from my employee table, and I'll run a simple group by operation. And this group by, I'll do it by department number. So here you can see I'm writing a group by operation in which I'm calculating the total salary for each department. So if I execute this query now, here what you will see is that in the output you will have two columns. The first column is department number, and the second column right now is coming as sum of salary, which is not again good to look at. So what I can do, I can give an alias to each one of these columns. So let's say total salary is the alias for the first column, and let's say I'll want to represent the second column as department number. Right? So I have given separate aliases to each selection which I'm making. Now if I execute this, you will see that the first column here is total underscore salary and the second column is department underscore number, which are the aliases which I have given over here. So aliases are a cool way of giving your own custom name to a particular operation that you are performing on any given column. Right? That's how you work with aliases using MySQL. So that's about aliases. So now with all of this covered, we can begin our discussion on joins. Now I again recollect the main topic which I had just said at the first slide for joins. So joins are used to bring data from multiple tables together. Okay, so if you have one table of employee, one table of projects, one table of works on, and you want to use columns from all these tables in a single query, you can achieve that task with the help of join. Now the joins in MySQL are of four main types. So there are four types of joins which we use. We have inner join, left join, right join, and cross join. And in order to understand each of these joins, this is a Venn diagram which is representing how each join functions. So I'll explain it with the help of a very simple example that will become very, very easy for you to understand what is happening. So what happens in joins? So in order to understand joins, I'll again take you back to the example of foreign keys. Remember that we have one table of employee and one table we have, let's say, works on table, in which we have information about an employee who is working on any given project. And the constraint which you have defined is what? Foreign key constraint, which is saying that the employee ID in the works on table is pointing to the employee ID in the employee table. Now, if you want to join these two together, so whenever you want to join, so what do we mean by join? Let's say you want to run a query in which you want to print the employee name and how many total hours he has worked in this company. So for doing this task, you will get the employee name from the employee table and you will get the number of hours from the works on table. So what you will have to do, you will have to perform a join operation, which will join the employee demographic columns from the employee table with the employee ID column in the employee table. And in order to perform the join, you need a column which is common to both. That is, you would want a column that can link the two tables together, and that is your foreign key. Because we have already defined a link between those two tables. Our foreign key is the link joining those two tables. So if I want the details about an employee ID 1, that is for employee ID 1, what is the name and how many hours has this employee worked in this company? So for doing that, all I need to do is search for the employee ID in the employee table, get the name of that employee, and then join it with the sum of all the hours that employee has worked in my current company. And that will give me the result. And that is how join works. So in order to perform a join, you would need what? Firstly, you would need to decide on the type of join, which I'll explain in a second. Secondly, you would also need a way to link those two tables together. So you need a common linking mechanism between those tables. So is there a column available using which you can join columns from both the tables together? Now, discussing on the types of joins, there are 4 types of join: inner join, left join, right join, outer join, and cross join. Actually, there are 5 types. I think they are missing one type here. I'll discuss all of these in detail. So here, inner join is basically a join in which you will, in the output, you will only get rows which are common to both the tables. For example, in the employee table, let's say you have employee ID 1, employee ID 2, and employee ID 3. But in the works on table, you only have employee ID 2 and employee ID 3. Employee ID 1 is not working on any project. So therefore, no project has been tagged in his or her name. So therefore, in the output, if you want only the employees who are working on a project, that is, they are common to both the tables, that is, their information is available in the employee table as well as the works on table, then you perform inner join. So inner join contains the intersection of the employee IDs which are common to both the tables. So intersection means that you want employee IDs which are common to both the tables. In left join, you have employee IDs which are all the employee IDs from the left table. So in our case, what is the left table? Left table is the table on which you want to bring the columns to. So in our case, if you want to join the employee columns to the works on table, so the works on table becomes the left table. That is, in the output, you want information about all the employees who are available in the works on table. So all the employee IDs who are a part of works on table, you want to bring information about all those employees. So then you use left join. Similarly, if you want to bring all columns from the employee table in the output, doesn't matter if those columns are available in the works on table or not, then you use right join. And finally, an outer join will contain columns which are available in both the tables. So either this or this. So there is a row might be present in either employee table or it can be present in the works on table. So a union of those is basically your outer join. So first, here's the syntax for writing inner join. So inner join, as I mentioned, contains the rows in which the employee ID will be present in both the employee table as well as the works on table. So the rows should be available in both the tables. And this is the syntax for writing a join. So I'll demonstrate the syntax by going into the MySQL workbench. So in this example here, let me write the comment first. So here what we are practicing the inner join. So in order to look at inner join, first I'll print some of the rows from employee table. So select star from employee table. First of all, I'm printing the rows from employee table so that we all know what columns we are dealing with. So these are all the columns from employee table. Secondly, I'm also printing all the columns from works on table because this is the example which I have been giving. So in the works on table, you can see we have employee ID, project number, and the number of hours which an employee has dedicated to a particular project. Now I want to join these two tables together. So I want to bring columns from employee table into my works on table. So please focus here and understand how we are defining the syntax. So you start your statement with the select keyword. Then right now I am selecting all the columns from the join table. So that's why I'm writing select star. Later on, I'll show you how you can choose a subset of columns as well. It's not like you always have to select all the columns. But since this is the first query which we are writing, so I'm selecting all the columns for simplicity. So after selecting, then you write the from keyword. Now, which is the left table? I want to bring the columns into my works on table. So therefore, I write works on. Then comes the keyword of left join. And on which table do I want to join that columns from? I want to bring the columns from my employee table. Right here, I want to bring the columns from the employee table on, or in this case here, after writing this particular keyword, all we need to define is basically the way in which you are joining these together. So here we have works on dot, I think the ESSN equals employee dot SSN. So this is basically how you write your complete inner join query. Sorry, we are writing an inner join, so let me write inner join here. Right now, this is how you define your inner join. So how we are defining this inner join? First, you write the table to which you want to bring the columns on. So I want to join the columns from employee table to the works on table. And which type of join I'm implementing? I'm implementing an inner join here. Then after that, you are defining how these two tables are related. So in my case, ESSN from the works on table is equal to SSN from the employee table. So basically join wherein the SSN ID from the works on table, here you can see this SSN ID Search for this SSN ID in the employee table and join the columns from the employee table to the works on table for that row. So if you execute this query now, you will simply see that in the output, on the left hand side, these initial three columns, right? So the first three columns that you are seeing in the output, this column, the next column, and the third column, right? So these first three columns here, these columns are coming from the works on table. Remember this, these first three columns, they are coming from the works on table, and the column from first name till the last, all these columns, they are coming from the employee table. And how they have been joined? So if you look at these two columns here, so you will find that the SSN ID from the employee table, so these two columns here will always be equal. So here if you match the rows here, so these employee IDs will always match, because for this employee ID, it has searched for the row corresponding in the employee table and matched the columns here. So that's why this condition is written here. So basically join the table such that the employee IDs from these two columns are matching. So here you will find that these rows have same values for each and every row, because that's how it has mapped the values from employee table to the works on table. And in the output, what you will find is that you will get the rows which are common to both the tables. So these are all the employees who are a part of your employee table, as well as the works on table. So there all the rows are available in the output. So that's about inner join. Just to recap, in case of inner join, the output contain rows which have IDs common to both the tables. That's how inner join works. Right? The next type of join which we will discuss is called left join. Let me open up that. In left join, as I have mentioned, the output will contain rows which contain all IDs from the works on table, irrespective of whether that ID is present in the employee table or not. Right? Doesn't matter if the particular employee is present in the employee table or not. All the logically speaking, if an employee is present in the works on table, he or she has to be present in the employee table as well. But a lot of times it happens that a table might not be containing, two tables might not be containing all the employee IDs. So if you want all the rows from one table to be available in the output, that is the left table this time, you would use a left join. The syntax remains exactly the same. There is no change in the syntax. It's just the preference that you have. So if you want all the rows from the left table to be in the output, you use a left join. Hope that makes it clear. The syntax is no change here. So in this case, in place of inner join, you will simply write the left join, and you will find all rows from the left table will be there in the output, irrespective of whether or not it is there in the right table. It doesn't matter. Even if it is not there in the right table, still it will be there in the output. So let me see if I can give you a quick demonstration of this as well. Let me share my screen. Let's go back to MySQL Workbench. So in order to demonstrate left join, let's use some other way of joining. Let's say now I'll use select star from uh, employee table, left join with the department table on employee dot d number equals department dot d number. So here in this query, what I want to do, I want to bring the department related information into my employee table. So remember, our employee table only contains columns about an employee. We don't have any information about, except department number, we don't have any other information about the department in which an employee is working on. So all we have is a number for the department. So here if you see in this output here itself, if you observe the last column, this is the department number column for the employee. So we only have the department number here. We don't have any other additional information about the department. And if you take a look at the department table, if you take a look at the department table, here you can see in the department table, we have some more additional information about the department. So apart from department number, which is a primary key, we have the department name, the manager ID for that department, and the manager start date for that department. So at what date is that manager managing this department? So now I want to bring the two tables together. So for that, I have written a left join. So now I want to keep all the rows in the left table. Right? So from all the department numbers which are available in the employee ID, employee table, right? So in the employee table, all the department numbers which are available in the employee table should be there in the output, irrespective of whether those department numbers are there in the right table or not. Right? So if I run this query, so what will happen is that in the output, you will find the initial columns here from here till this department number. These columns are part of your employee table, and the columns following the D name, these four columns here, these are a part of your department table. And now, as I had mentioned, it's not mandatory that you have to make a selection on all the columns again and again. Let's say you only want to print the employee first name, last name, and the department name. So now it will essentially select first name from the employee table, last name also from the employee table, but this department name will be chosen from this department table because it has been joined together. So it will not throw you any error. So now if I execute this query, you will see that in the output this time you have three columns, wherein the first two columns are part of your employee table, but the third column is part of your department table. So now you are able to print information from two different tables in a single query. And the opposite of left join is right join, in which all the rows from the right table will be there in the output, irrespective of whether that value is available in the left table or not. So that's the only difference. Apart from that, there is no other difference. All right. So I hope all these joins, three main types of joins which are available in MySQL. Apart from this three join, there is a fourth type of join as well, which is called cross join. But unfortunately, cross join cannot be implemented in MySQL. But there are other flavors of relational or SQL, like MySQL Server or Oracle DB, which implement outer join as well. So if you want to practice outer join, you can use some other flavors as well. I'll just tell you about the theory of outer join. So the theory of outer join says that if you implement an outer join, then it will contain all employee IDs. Either it might be present in the employee table or it might be present in the department or in the works on table. Doesn't matter which table it is a part of. Either it can be present in the left table or it can be present in the right table. The output will contain IDs from both the tables. Right. So that's all about the outer join. So these are the four joins. Which four joins we have discussed till now? We have discussed inner join, left join, right join, and outer join. Now there's a fifth type of join which is a little bit special in a way that you don't need to specify how those two tables are joined together. And that type of join is called a cross join. So now cross join is a little bit different, as I mentioned again. So we have discussed all these. In case of a cross join, it's basically like a Cartesian product between two tables. Now you might be confused what exactly is a Cartesian product in the first place. Let me explain what a Cartesian product is. That's why I'm using this tool. So imagine that you have two sets. You have one set A. So here you can see I am just drawing a set A. In this set A, you have three values, A, B, and C. So you have three values in set A, B, and C. And then you have some other set in which you have three values, 1, 2, and 3. Now, if I ask you to perform a Cartesian product of the values in these two sets, so Cartesian product is nothing but you will create a set in which you will create all possible combinations of items from these two sets. So what will happen? The first combination will be A, 1. The second combination will be A, 2. Third combination will be A, 3. Then you will have B, 1, B, 2, B, 3, C, 1, C, 2, and C, 3. Right? So you can create 9 possible combinations here. And this is basically what Cartesian product is. So a Cartesian product is nothing but in Cartesian product, all you have to do is basically join each row from A table to each and every row from B table. Right? So if you are implementing a Cartesian product between two tables A and B, the end result will contain a table in which each row of table A is matched with each and every row of table B. That's what Cartesian product is all about. Right? So let me demonstrate the Cartesian product going back to your MySQL workbench. So I hope I have explained Cartesian product with the help of this simple set theory example. Now what we will do is that I'll simply explain this concept using MySQL workbench as well. So here I'll now write cross join. It's a very simple operation. Here, in order to explain this, I'll first show you the individual tables which we are going to do a cross join on. So select star from the departments table. Okay, so here, this is the departments table that we have. Name is department. So here you can see this department table has 3 rows for department 1, department 4, and department 5. So we have 3 rows in the department table. And second table which we can use here, I just want a table which is not that long. Second table, let's use select star from project table. The project table also contains, I think you have 1, 2, 3, 4, 5, 6. So the project table contains 6 rows. So here now, if you implement a cross join, so select star from project table, cross join with the department table, MPNT department table. So here in the output, as I mentioned, you have 3 rows in the department table, you have 6 rows in the projects table. So the output table which you will create will have 18 rows, 3 times 6, wherein each row from the project table. So here you can see this first row is the first project, right? So here you can see the first row from the project table is joined one each time with each and every row from the department table. So in this case, you can see for project 1, it's matched with department 1, project 1, department 4, project 1, department 5. Then you can have project 2, department 1, project 2, department 4, project 2, department 5. So each row from project table is joined with each and every row from the department table. And that is what cross join does. So it's nothing but a join in which you match each and every row from both the tables without applying any constraint on which column you need to match and such. Right? So there is no constraint which are applying at any given point. Right? So that's all about the cross join as well. So till now we have discussed all 5 types of joins. We have discussed inner join, left join, right join, outer join, and cross join. Whenever you join a table with itself, you call it a self join, but it's not anything different. So you can apply a join with a table itself, right? So whenever you want to, let's say in case of employee table, against each employee you have the manager ID. But now instead of just writing manager ID, you also want to write manager name and manager department. Then you can join a table with itself. That is, write a self join. So again, a self join is nothing but a join in which the table is joined with itself. So a self join can be either of inner join, left join, right join, whichever you want. So it's nothing special. It's one of the 3 joins which we have already discussed. The only new thing about here is that it's given a special name because here you join a table with itself. So therefore you call it a self join. That's it. And even you can use joins to filter the data. So this is the last topic which we will cover today, in which I'll tell you a neat trick which can very easily allow you to perform filter operation at the time of join operation itself. So here, let me write a simple query here. So let me write inner join and filtering. So I'll do a simple join operation. So select star from employee table, inner join with, let's say, department table on employee dot d number equals department dot d number. So right now, if I print this result, what will happen is that it will contain all the rows from this join operation. Right? So right now it will contain all the rows from this join operation. But this time, let's say you don't want all the rows in the output. Rather, let's say you only want the rows in which the department number equals 5. So now what will happen is that instead of writing or printing all the rows, you will only get in the output rows for which the department number will be equal to 5. So whenever you are doing a join operation, instead of just writing the condition using which you are joining the tables together, you can also write some filter conditions after that. So in this case, one filter condition that we are applying is basically the department number should be equal to 5. If you don't want to be working on the department number, let's say you want all the employees whose salary is more than let's say 40,000. If I execute this query now, it will show me all the employees details, and the details will be printed from both the tables. Please see here that in the output, the columns which are coming are from both the tables. So these initial set of columns which I highlighted, these are coming from the employee table, and these set of columns here, they are coming from the department table. But since I have written a filter condition, this filter condition will allow me to filter rows while applying the join. So it's much faster than writing a separate where condition. So this here is much faster than writing a separate where condition after you have completed the join. All right. So